Alright, we're continuing with area, but before we did area just of like flat surfaces, okay, two-dimensional surfaces. So, oh my, look at that. Phil, let's change that. Let's try this again. Alright, so, you know, we did that. We did area of, of triangles, right? Or correct. Alright, so, we did, these are all flat figures, okay? There's just two dimensions. They just have a length and a width, basically. Alright? Everybody understand all that? Then we had different crazy things like this, right? We did that as well. But everything's been two-dimensional. Even though it's got a whole bunch of sides, it's only got two dimensions. It's got a length and it's got a width, basically. It doesn't, like, come out at you, right? That would be the third dimension. Well, guess what we're finding the area of today? Right, that third dimension. Okay, so we're gonna. Oh, where'd that come from? So we're gonna talk about things that are in 3-dimension, and we call those solids. In geometry, they call them solids because it's not just a flat surface. It's something that you can actually look around, right? You can kind of take it and twist it around. It's got more than just a length and a width. Everybody with me on that? So the first thing, just up there. So first thing we're gonna do is, let's write this down. We don't just call it just regular area. We don't just say area. We are going to call it the surface area. Alright, so we're going to do the surface area of prisms and cylinders. So first of all, we've got to figure out what a prism basically is. Well, prism can have all kinds of different shapes, just like anything, I guess. But it all depends on the base. Alright, it all depends on the base. So you could have a prism with a base that looks like this. Okay, that is a square or a rectangle or any four-sided figure. Or you could have a prism that has a triangle as a base. You could also have a base like this. Now when I talk about a base, now remember we're talking 3-dimension. This is just the base. What happens with all these things? Pretend this is like an overhead view. Alright, you're looking straight down at this thing right here. But it rises up. It's hard to show on, because this whole screen is 2-dimensional. It's hard to show it on 3 dimensions. But you got a base like right here which is flat and it goes up. Alright, so you could have a square that goes up. You could have a rectangle that goes up. You could have any shape on the bottom. But what happens? It goes straight up. Alright, so when I say straight up, usually I don't like to say that. So what do you think? That would be the height. It would be perpendicular, right? Perpendicular to the bottom, or to the, I believe. I think we're only finding the areas of right solids. I don't see where it says it in here, but I think that might be the case. Well, anyway, that's what we're going to basically do. So it's hard for me to draw these pictures, especially, well, by hand it's really hard. I might be able to, it's a little bit easier maybe to do it with this program, but I actually went through earlier today and found some shapes online, and I'm just going to find them right here. So let's start off with an easy one. Let's start with the triangle. Okay, and let's make it a little bit bigger so we can see it. Alright, pretty cool, huh? So this is a prism because it has a base. Now, it's not really sitting on it right now. Look, if I took this thing and I, tilted it around so it could sit on that triangle, you could think of it as the base. But just because it's sitting on the base doesn't mean that's, if I take it and twist it and move it around, it's still the base no matter how I have it sitting. Does that make sense? So this is the base. And it's got another base as well, not just one, but you can kind of see through a little bit, can't you? Right back in here. So this would be one base, and this would be another base back in here. Do you see how it might go like this? Does that make sense? About right in there. Okay, so that would be a base, this would be a base. So in order to find the surface area of a prism, and this goes for a cylinder as well, but watch what we're going to do. I'll just put SA for surface area. Is that all right? The surface area. You basically need to find 3 different things. And in fact, the first 2, I don't even know if it should be called like 1A and 1B or something, but I'll just call it 1, 2, and 3. So if I wanted to find the area of all these surfaces on this prism, prism right here, this triangular prism. I call it a triangular prism because the base is a triangle. Okay. Then I would find the area of the bottom. Or you could just say both bases. I don't know. A lot of times we like to think that it's sitting on something, so we got a bottom and a top. Okay, this just, to me, it just makes a little more sense because I try to visualize it. So I've got a bottom, I got a top, right? Or you could call that the top, and you could call that the bottom. Doesn't matter which one. What do you think is true about the top and the bottom, though? They're both the same. Okay. So really, do you understand why I say 1A and 1B? Because you find one, and the other one is exactly the same thing. So it's not like you're really finding two different things, right? And you also have all the sides of this thing. Now, instead of calling it sides, we're going to give it a fancy geometry word, and we call it the lateral surface area. Does that look like it's writing weird? Why is it writing like that? Surface. Looks like there's a line through it. Do I have like a line in here somewhere? That's weird. Well, we didn't talk about the area of it, I don't think, did we? Did we talk about volume? Yeah, because that's in this chapter. I don't know if we did or not. I don't think we did. But anyway, we call it the lateral surface area. I think we talked about lateral something. I can't remember, but that's okay. Lateral surface area. Lateral basically means the sides. All right, so lateral means sides. S-I-D-E-S. Okay. Alright, that's fine. We're going to talk about it again. Alright, so anyway, the lateral surface area means all the sides of this thing. Now, let me show you something. In order to find the lateral surface area, I have a little, like a little sub equation or formula. That's what I wanted to say for this. How do we find the lateral surface area of any right prism? Okay, this is what we do. We find the perimeter of the base. Alright, so you take the perimeter of the base and we multiply it by a height.
What is dot F?
Dot F.
Yeah,
no idea. Oh, come on. I said it. Come on, come on. I know it might not look like an O, but I even said it when I wrote it out. It's the perimeter of the base times the height. So that's how you find the lateral surface area. Okay. Trying to think. I didn't do this in the other class, but I think we might be able to do it in here. Let's use blue. Will probably stand out. Let's do this. Let's say the length from here to here, I'm just making these numbers up. Let's say that's 10. Alright? And let's say, now this is kind of slanted. Do you see what I'm doing right here? Because they just kind of took the picture and tilted a little bit, so it looks a little bit slanted. But that would be the height of that triangle, and then this right here would be the base of that triangle. Do you agree with that? Yeah. Alright. So let's call it, I'm going to throw all the numbers in here, so we don't have to like solve for anything. We just plug it into our formula. So, I don't know, give me, if that's 10, what do you think this might be?
5.
Maybe like 5, okay? And let's make this base, I don't know, let's make it 4. Is that alright? Okay. So, if I wanted to find the surface area of this whole entire thing, which means I want to cover it up with paper, or I wanted to paint it, or I wanted to, you know, draw it in or something, and I want to cover every little bit of surface of this, and I wanted to find out how much area do all these surfaces add up to be. This is what I would do. I'd find the surface area of the top and the bottom. Well, this is, or the base, if you want to consider that. That's an ugly one. Let's try this again. There we go. These are the two bases. Would you agree? If you want to call it that, you can call it top and bottom, whatever. But they're the two bases. Now, when I say the base, I'm not just talking about 4. I'm talking about the base of the whole entire solid. Okay. How can I find the area of this? Well, it's just a triangle. So how do I find the area of a triangle? It's 1/2 base times what? Height. That's 20. Half of that is what? 10. Now, that's just this red one right here. What about the other one? Right here. What would that be? It'd be the same exact thing, wouldn't it? So that would also be 10. You with me so far? Is that the surface area of the whole entire thing? No. We got to find the rest of the sides too, don't we? Now some people say, yeah, but look, I could just figure this out. I could figure out what that length is and just say, oh, 10 times that length, and then do that. How many are there? There's 3 of them. Yeah, there's all kinds of ways you could do this, but I think this is the simplest way to do it in general. Just find the perimeter of the base times the height. So, oh, you still have to find this thing right here anyway, wouldn't you? So we still have to do a little bit of math. So we got to find the perimeter of this triangle right here. Any way to find that perimeter? What do you think? Let's redraw the triangle. I'll just sketch it by hand. And then, does that make it a little easier? So the whole bottom is what? 4? That's 5. But I want to find the perimeter of this triangle. Let's say it's...
Or do we assume that that angle is bisected?
It's a great question. I think we're going to have to. That's a good question. Yeah, because if it's not, yeah, you wouldn't be able to do this. Exactly right. What's that? I'm trying to find the perimeter of the base now, because I'm trying to find the lateral surface area. So I'm trying to find the perimeter of the base. So I want to find, you know, this this bottom right here. I know that's 4. I just got to find these 2. All right, and in order, yeah, with this information that's given, let's just say that these 2 are equal to each other. Okay, so so what could we do? We could say that's 2, couldn't we? And then how could you find this?
It's 5.4.
You could just do Pythagorean theorem, couldn't you?
Yeah.
Okay, am I right on that?
Yeah.
Okay, so I've got 2 squared plus 5 squared. So let's just write it out. 2 squared plus 5 squared equals, I don't know, call it c. C squared. Okay, that's 4, and that's 25, and that c is the square root of 29. All right, so that is the square root of 29. So what is this right here? That's also the square root of 29. We just made this up. I don't even know if they give you anything like this in the book or not, but I'm just thinking off the top of my head here. And so what is the perimeter of this base then? Be square root of 29 plus square root of 29, which is 2 square root of 29, right? Plus what? Plus 4, right? And what I'm trying to do is I'm trying to save the calculator for at the very end as much as I can, instead of, you know, doing every little step in a calculator and getting all these rounded values. And then I multiply it by the height. What's the height of this whole entire solid? It's 10, isn't it? Now, not of the triangle, the whole entire solid, because we already found the perimeter of the base, didn't we? So we found the perimeter of this thing right here. Now I got to figure out how tall this thing is. Remember, if I took this and stood it on end, how tall would it be? It would be 10, wouldn't it? I know, it is a little confusing, but it's just the height of the solid. All right. So watch. You could plug all that stuff in, and then you got the lateral surface area. What do you do once you get that number? Yeah. So that's the sides, add it to the top and the bottom, which is 20, and then you've got the whole entire surface area of that thing, of that solid. That was a little more confusing than I originally intended. Sorry about that. But you can kind of see what it involves, though, doesn't it? All right. Sometimes if you want to find the perimeter, sometimes you have to think a little bit on how to find the perimeter of this thing. And it all depends on the information that they give you and that kind of stuff. Now, if you look in the book, they give you all kinds of crazy formulas. See everything in white right there? That's really all you have to remember. Because this will work whether your base is a triangle, whether it's a square, a rectangle, a pentagon, a hexagon, no matter what shape this is, if you can find the area of this solid right, or this base right here, you should be able to find the surface area of the entire thing. Leah? Well, both bases are going to be 20. Just this base right here is just 10, but then the other one is 10 also. So this is 10 and this is 10. That's why I have both 10s right here. So the two bases are 20 altogether, added to whatever that is. I didn't bother going through this, but you could go through this and figure out what that is. Add those three things together, 10, 10, and this, and then you've got the total surface area of that object. All right. Let's do another picture here. I'm not going to put any numbers in there. I probably got a little ahead of myself. by doing that. So let's go to this one. Let's look at this crazy one right here.
When do we get our test back?
I don't know. Let's just pay attention to this. Look at this. How many sides is this? 1, 2, 3, 4, 5, 6. So it's a hexagon, right? So what they call it, it's still a prism, but they call it a hexagonal prism. Why hexagonal? Because of hexagon, right? Hexagon, hexagonal, or you could just call it a hexagon prism. But they probably say a hexagonal prism. And
Also rectangle.
so that's pretty interesting. Look at the bottom and the top. The bottom and the top, they are parallel to each other, right? And they're exactly the same. See, these lines go straight up, and it's perpendicular right here, just like we said it should be. And so that works with our little formula. So how would I find the area of this thing, of the surface area of the whole thing? Well, I would find both bases, right? So I'd find base 1, and then I'd find base 2, and then I'd also find what? The lateral surface area. How do I find the lateral surface area? Find the perimeter of the base times the what? Times the height. So let's figure out what we would do here. I'm not going to put all the numbers in, but how in the world would you find the area of this thing right here? Well, we just had a chapter, didn't we? How to find the area of a regular hexagon. Remember that? I'm not going to go through all that. You're going to have to look back. We had a test and everything on it. Okay, so find the area of the regular hexagon. So that's the bottom. So the base is, yeah, it's that 1/2 A times P. Remember all that stuff? Okay, so if you're going to do this, it would be the area is 1/2 the apothem times the perimeter, right? So you're going to have to go through all that, figure out what that is. And then the top's going to be the exact same thing, so that's nice. So you got the two bases. Then you find the lateral surface area. How do you find that? Well, you find the perimeter of the base. But look, if you found the perimeter to find the area, you already got perimeter anyway, don't you? So you got the perimeter of the base multiplied by the height. Which one's the height, though? It's this one right here. I should make that a little darker, shouldn't I? All right, so it's that one right there. All right, so that would be the height. That would go right there. And then you've got the total surface area of the whole entire thing. So you add up the two bases. So you figure out what this base is. Sometimes it's easy, sometimes it's not. Sometimes they're going to come straight out and say the base is whatever and give you a number. Sometimes they'll tell you what the base is. Sometimes you have to figure out what the base is. All right, just all depends on what they give you for this problem. But this is the key right here. That thing right there. That's huge in what we're trying to do. So you find the area of the base, two bases, and then you find the lateral surface area. How do you find the lateral surface area? It's the perimeter of the base times the height. Add all three of those things together, and bang, you've got your total surface area. Does that make any sense? I hope. And the nice thing is that works for a bunch of those things. I think there's another picture. Let's see.
Do all of them.
Prism octagon.
Yeah, let's use that one. That's pretty cool.
It's like 95 feet.
All right. Now I'm not going to go through this whole thing, but it's just so that we could see what we're going to do. Now, what if I wanted to find the total surface area of that? Well, again, I find the area of the base, right? It's an octagon. We talked in the last chapter on how to find the area of an octagon, so you find that. Add it to itself, right? Because that would be the other side. And then find the lateral surface area. How do you find the lateral surface area? It's the perimeter of the base and then times the height. Which one is the height? It's from here up to here. That would be the height of it. You understand that? When I say the height, think of this thing sitting on the ground, right? And then going straight up in the air. So that's what that would be right here. Okay? Yeah, but it doesn't go straight up, though. When it sits on the ground, all the sides don't go straight up. So that can't be the base. Would you agree? Because some of them slant up, don't they? So when it sits on the ground, all the sides have to go straight up, perpendicular to the base. Look, this side right here is not, if you say, well, wait a minute, but it's sitting on this side right here. But are all these sides perpendicular to that base? No, so that can't be the base. All the sides have to be perpendicular to the base.
So the only object that any side can be a base is like the perfect cube.
Now, it doesn't have to be a perfect cube because it could be a rectangle. You could have a rectangle and still go straight up in the air. It's not a perfect cube. So it can be any kind of shape as long as the sides go straight up. Now when I say straight up, what does that mean? It means perpendicular to the base. Allie?
If you made a line through the green part, and like through the middle, wouldn't that be perpendicular to that one?
Let me show you. Let's pause this. Okay, along the same line of, listen to me, along the same line of the prism is a thing called a cylinder. So here's a nice cool looking cylinder. Yeah, I can actually draw a cylinder. Some of the other things I'm not very good at drawing, but this one I probably could. But let's take a look at this. The nice thing about learning the formulas the way I learn them, okay, or the way I teach them, I guess. I learn them that way too, I guess. But is, let me change a couple things here. Is really we're not learning anything different. The formula for the surface area of a prism is the same thing. This is called a cylinder. It's really the same thing as a prism because look, you got a base here and you got a base on the bottom. Everybody see that? All right, and the sides go straight up, don't they? Except the sides are now nice and curved, aren't they? They're not just straight lines, but it is perpendicular. This would be the height. Let's get a nice dark color. So from here to, let's see, the middle will go about right there, to there, that right there is the height of this cylinder. It's supposed to be an H. Okay, that's the height of the cylinder, just like it was when it looked like a prism. Okay, now it's actually sitting on end, which is kind of nice. But sometimes they'll have these cylinders drawn where they're sitting on their side. Just because they're sitting on their side, does that mean that's the base? No, these ends are the bases. You got it? Top and bottom, if you want to call it that. So that would be your height. So the nice thing about a cylinder, it's basically the same formula as the surface area of a prism, except we're talking about a circle. They've done that once before. Remember we talked about perimeter of different things? But then we said the perimeter of a circle, we give it a special name. Just because it's a circle, right? Circumference, right? We call it circumference. So instead of calling this a circular prism, which I guess they could, right? Because would we have a triangular prism, a rectangular prism, hexagonal prism, an octagonal prism, whatever you want to call them. We could have called this a circular prism, but for some reason, they give it its own special name, and they call it a cylinder. Everybody with me on that?
Yeah.
Okay. So how do we find the area of the cylinder? The same way, I'll put surface area, not just area. How do we find the surface area of a cylinder? Find the area of what? The top. Find the area of the bottom. It looks like a D, doesn't it? Bottom, how's that? And then we find what? All the sides. Look at all the sides. What do we call that? The lateral. Oops. Getting ahead of myself. The lateral surface area. How do we find the lateral surface area? We find the perimeter of the what? Base. And we multiply it by its height and how tall it is. Alright? So this is the height right there. Perimeter of the base times the height. Same exact formula, isn't it? Alright? There are books, and I think this book does it as well, that they throw in a bunch of other stuff. Some books would do this. What is the area of either the top or the bottom? Just the formula for it. It's pi r squared, right? Okay, so that would be the top, plus the bottom would be what? Pi r squared. You said it so fast, I had to think that you were saying it right. Because when you usually just burst out with an answer like that, it's nowhere close. But but this time you got it right. And then plus, so that's the top, that's the bottom. What's the perimeter of the base? What do we call the perimeter of the base? Circumference. And what's the formula for circumference? Yeah, let's go r. We're using r in this, so we'll use 2 pi r times the height. And we'll call the height h. Okay? So some books will write it like this. They'll say, oh, memorize this. 2 pi r squared plus 2 pi r h. Is that really something you want to memorize for the area or for the surface area of a cylinder? I mean, it's true. I mean, it's true if you could memorize it and just plug a bunch of stuff in, but I don't like that way at all. It's too much memorizing. It's too many r's and pi's and h's floating around. I can't keep straight of them all. So what I do is I always memorize the same thing. This is what I memorize. And then I just break it down from there. I look at the top. I don't memorize a specific formula for this. I just say, okay, let's find the area of the top. What kind of shape is the top? Well, it happens to be a circle. Well, I know the area of a circle, pi r squared. Let's find the bottom. What's that? Well, same thing, pi r squared. What about the lateral surface area? Perimeter of the base. Oh yeah, it's a circle. I know what the perimeter of a circle is. It's what? It's 2 pi r. And then times the height, stick the h right there. Does that make sense? So instead of memorizing this thing right here, this is what I memorize. Okay, I remember this, and then I could figure out this stuff right here. You guys are watching, right? Does that make any sense to you? I mean, I don't think you really fully appreciate what I'm trying to tell you until you look and see how other books, and even this book, tries to teach you this stuff. They show you all these different formulas. And in fact, some books, I didn't look in here yet, but some books will give you like a whole big old chart in the back of the book with all these different formulas. Here's the surface area of a cylinder, and they give you some crazy thing like this to memorize, and they'll say, okay, well, here's a surface area of a triangular prism, and then you got to memorize all these things. Well, here's the surface area of a whatever. It's too confusing. Remember this, and that's all you got to know. Okay? All right, here is your homework.
There's no homework tonight. 'Cause I got it right.
Well, now I just might double it for that.
Yes, please do. Because double times 0.
And you give me another answer sheet.
Did I what?
You give me another answer sheet too.
I gave you another one? Or do you want one? What do you
No,
ask?
you gave me one.
Okay, well.
She said they
So you're not going to stick around and see what the assignment is? You're actually going to walk out of my room while I'm writing it down? So I made it a little easier for you. And I'm just having you do the odds. Okay? So that, and that section, remember it's 2. We skipped 1, so it's 12-2. Put 12-2 at the top
Do
of
you
your
want to fill this
paper.
out for me?
Okay. Yes. What is it? One of those dumb things?
Yeah.